we have a main activity, we have a layout, and we have a button in that layout which we need to locate to attach a touch listener so that we can run some arbitrary piece of code when the user fondles our widgets. So before we do that though, let's take one step back just to make sure everyone is on board with what's happening so far. When our application launches, the first thing to happen is that main activity is instantiated. There's nothing magical about this class. There's nothing magical about the name. The only reason this class is instantiated at start is because we've told the operating system to do that with our Android manifest file. Here's the activity defined. Here's a property we have set on it, telling it to run in landscape. And then we have intent filters here, which says that this is our launching activity. You can read more about the manifest on the course website, but this is what you need to know for now. So in main activity, once it's created, the operating system calls on create to let us know that that's going on. That's before this thing becomes visible on screen. The first thing we do then, as well-behaved developers, is call the superclass to let it implement all the default behaviors. This saves us from a ton of boilerplate. We are extending from app_compat activity, and so we just call on create on that. We pass up the same argument we've got. The bundle is basically used to load data that we've packed between sessions. So this will be empty, but it doesn't matter. We pass that on. We let the superclass do default behaviors. And then we set our content view to fill the screen with our layout from the resource packages. So we want to do the same thing with, well, not the same thing, sorry. What we want to do is locate the button using an ID in the same way set content view does. So let's just create a button. I'm making this final because I'm not going to change the button, right? I just need to locate a reference for it. Let's call it start button. And I think it's find view by ID. And that takes an integer ID reference. So these are all precompiled assets. It's faster than you think accessing stuff like this, but it's not something you want to do in real time. Yada, yada, whatever. So as always, our resources are in R. And in this case, under ID, I have start button. Let me just, this is obviously what I want, but I'm just going to double check that that is in fact what I called it. It's faster to do here in text. Yes, we create an ID called start button. So this should be the button. Once I have the button, we can tell it to listen to touch, set on click listener. And now you can do this with a Lambda. You can provide it with an executable here, a runnable rather, sorry. But I'm going to just pass in the reference to our own instance, to the main activity. Now, our activity is not a touch listener, so we don't implement that interface, but we can fix that by pressing Alt-Enter and make main activity implement Android on click listener. We want that method. There we go. So now we have an extra interface defining a single method, which is this. On click is triggered with a view. That view is, whatever was touched to trigger this event. In our case, we're only listening to a single view and a single widget, right? There's only a single button. Otherwise, you'd have to check in this method what it was that triggered the event. Right now, we can safely assume that it's going to be our start button, so we want to launch our separate activity. So the game activity needs to exist for us to launch it. So let's start there. I can click on this package name and just do a new Java class. I realize this is stupid because what we want is an activity. So let's use the wizard instead. A new activity, pick an empty one. We want no frills at all because we're going to do all of our own work in here. I'm going to call this game activity. And I don't want to generate a layout file. We're going to draw our own pixels. We don't want the layout system at all. So this is fine. App_compat absolutely keep. Finish. So same thing as in the main activity, right? We have an on create. It calls the superclass. All is fine. So now to launch this, in Android, the way we launch new activities is by way of intents. That's basically how we communicate between all Android components. So we're going to create an intent. Let's make that final because I'm not going to change it. Always, when you get the chance, declare your variables final. Like const variables is a huge performance benefit, so make sure you make use of it whenever you can. So a new intent takes 2 arguments. It takes the context that we're coming from and the class name that you want to be instantiated. So in this case, the context is this. An activity is always a context as well. New intent, and then this is, let's see, GameActivity.class. I think it's like that. We need to call start activity with our new intent, and then we want to finish the activity we're currently in. And I think that's it. Let's see if this compiles. Where am I? Here we are. Perfect. Yeah, so clicking the button launches an empty activity. Now the game activity, completely blank, we need a view in here as well. I want that view to be the game, so I will create a new class. Let's start with a new Java class. I'm going to call this game, because it's going to hold all of our game logic, the update, the rendering, all of that jazz. I want it to inherit from a view, something that the Android system provides us that takes part in the system's rendering processes, but also gives us access to event handling and the events we care about. The perfect class for us is the surface view. The surface view allows us to draw arbitrary pixels. It basically gives us access to the frame buffer, so we can draw whatever we want, and it gives us touch events. So we're going to do surface view from Android view. And for interfaces, and this is important, we're gonna implement runnable. We will have a separate thread to execute our core game loop. The surface, sorry, that's not the surface view, that's a surface. Sorry, I want surface view. There we go. The surface view has rendering callbacks from the operating system like all other views. They get executed 60 times per second, and that's called from the UI thread. The UI thread is sensitive. Android do not allow you to cause latency. Like if you do heavy calculations in the user interface callbacks, then your phone will appear sluggish. You will have lag. You will have choppy scrolling. If Android notices that your app is doing that, it might kill you. It will degrade your app. Degrade is the wrong term, but anyway, it will lower your app score on the Google Play Store. There's all kinds of repercussions for being a bad member of the ecosystem. So you want to keep all calculations out of the user interface thread. And we do that by rendering on a separate thread and then just putting those images to screen on the UI thread. Sorry, that's a long explanation, but we'll get into the details once we're in here. I don't want to implement inherit from thread. I want to inherit runnable. Yeah, that's what I want. So that a separate thread can execute our class methods. Let's see how that looks. So game extends runnable. Surface view implements runnable, yes. So the first I want to do is implement these methods. I want a run for my thread to execute. And just for sort of looking ahead here and planning a bit, I will want this to execute the core game loop. So while the game is running, I want this to continuously execute input, update, and render. That's all the work a game can do. And we're going to do that in a separate thread. And then from surface view, I want a constructor taking a context so that I can instantiate this class. And then I'm going to need some lifecycle callbacks as well. So my game now needs to call the super. Yep, this looks good. Simply needs to be created in our game activity and then added as the view put on screen, right? So let's make a member game. I use underscore for my members. The Google Android style guide says we shouldn't use prefixes, but I strongly prefer to know when a variable is a member so that I know what scope it's coming from. I get confused if you have you know, you have names appear in a method that aren't declared there. I need to know where they're coming from. So I always prefix members with an underscore. You don't have to do it. You can use an M like old style Java developers if you want to, or not at all. I don't care. So game equals new game. It needs a context. And like I said, an activity is always a context. So we pass in this. The context is what we use to access R, so we can get to our resources, for example, or if we need to save to the hard drive, to the file system, we need to go through the context of the application. We have the game, so then we can set content view, because our game is a surface view. We pass in game. Lastly, also, like this should compile and run. It's still a blank view, of course, but, you know, at this point we can start the game, but we can actually finish the game activity. It's not going to have a lot of content. We want to override a couple of the lifecycle callbacks. So I want one for on pause, one for on resume, and one for on destroy. So on pause calls super. Sorry, that's not at all what I want. Super on pause. Then I want to copy paste these. Wait, why are we complaining? Game activity extends another activity. Ah, sorry, it doesn't have a return type. There we go. On pause, on resume, on destroy. Always call the parent class. And then in a little bit, we're gonna call the same methods that we declare inside game, so that the game is aware of the life cycle as well. This should be on resume. This should be on resume. And this is on destroy. If you haven't read about the life cycle on the student portal yet, go do that. On pause and on resume are the two events that we can reliably get. On destroy might not happen, on start and on stop might not happen, but on destroy I want to have listening to either way, because there is cleanup I want to do if there is a chance for us to do it, particularly when it comes to dealing with audio, so I'm going to keep that. But on pause and on resume are our workhorses as game developers. That's when we know that we are not just in view, but in focus. We are the top level application, and so the game should be running versus not. So I think that's it. Let me compile and see if this runs. While that's compiling, I'm going to check the timer. This is 12 minutes, so in the next video, we're going to flesh out what the game is actually going to do. This still works. Perfect. So I'll see you in the next video.